To understand the tragedy of a disappearing king, we must first understand the kingdom he was built to rule. Before the first snowflake falls, before the sun dips below the horizon for months on end, there is a landscape that defies the logic of the rest of our planet. This is not merely a wasteland of cold. It is a dynamic, living architecture of frozen water. The Arctic is a world built on a paradox. It is a desert of ice, yet it is the most structurally complex environment on Earth. We often think of the Arctic as a static, frozen sheet, but it is more akin to a breathing organism. It is composed of a delicate layering of sea ice, multi-year ice, and seasonal flows, all dancing atop a deep, dark ocean. This is the architectural ice, a platform that is constantly being built by the freezing of seawater and dismantled by the rhythmic pulse of the tides and the relentless battering of Arctic storms. This ice is not just a floor, it is a biological bridge. It is a crystalline highway that connects isolated islands, allowing for the movement of life across thousands of miles of open water. It serves as a complex topographical map where pressure ridges, massive walls of jagged ice pushed upward by colliding flows, create microhabitats for specialized life. These ridges act as windbreaks and snow traps, creating the very drifts that will eventually become the dens of the Arctic's most iconic inhabitants. But the architecture goes deeper than what the eye can see. Beneath the surface, the ice is a chemical factory. As seawater freezes, it undergoes a process called brine rejection. The salt is pushed out of the growing ice crystals, creating hypersaline pockets of water known as brine channels. These microscopic veins of liquid salt within the solid ice become a sanctuary for specialized algae and microbes. This microscopic foundation is the true beginning of the Arctic food web. Without these brine-dwelling organisms, the entire engine of the North would stall. This landscape is defined by its seasonality. There is the freeze-up, a period of rapid structural hardening, and the break-up, a chaotic period of fragmentation. For most creatures, this is a cycle of extreme rhythm. For the polar bear, however, this architecture is not just a home, it is a specialized tool. The bear does not merely live on the ice, it is an extension of it. The very cracks, the leads, and the edges of these shifting plates are the bear's primary hunting grounds. In this frozen realm, geometry is destiny. The thickness of a flow, the stability of a pressure ridge, and the timing of the seasonal melt dictate whether a predator thrives or starves. It is a world of precision, where every crack in the ice is an opportunity, and every shifting plate is a potential catastrophe. To look upon the Arctic is to see a masterpiece of natural engineering, a crystalline empire held together by nothing more than temperature and salt. It is a kingdom of immense, fragile complexity, designed by physics and perfected by evolution. And it is a kingdom that is currently beginning to lose its foundation. How does a creature born of the forest learn to conquer the sea? To witness a polar bear in motion is to witness one of nature's most profound anatomical transformations. While they belong to the order Carnivora, the polar bear, Ursus maritimus, has drifted so far from its brown bear ancestors that it has essentially rewritten its own biological blueprint. It is no longer a terrestrial predator. It is a marine mammal, a specialist so finely tuned to the Arctic that it has become a prisoner of its own perfection. This transition began hundreds of thousands of years ago, a slow-motion metamorphosis driven by the relentless pressure of the ice. As the climate fluctuated, a lineage of bears began to exploit the untapped bounty of the frozen ocean. But to survive in a realm of sub-zero temperatures and salt-crusted winds, standard biology was not enough. Evolution had to engineer a masterpiece. Consider their skin. Underneath that iconic coat, a polar bear does not possess white skin. It possesses black skin. This is a sophisticated solar collector, designed to absorb every possible photon of light that penetrates the fur, channeling thermal energy directly into the bloodstream. This heat is then trapped by a coat of guard hairs that are not actually hair at all, but translucent, hollow tubes. These follicles act as fiber optics, channeling light deep into the undercoat while simultaneously trapping a layer of insulating air. But the true secret of their survival lies beneath the surface. A polar bear's fat layer, or blubber, can be up to 11 centimeters thick. This is more than just a caloric reserve. It is a dynamic thermal shield. This adipose tissue allows them to endure long swims in near-freezing waters that would trigger immediate hypothermia in almost any other mammal. Even their very blood has been re-engineered. To prevent the freezing of vital fluids, polar bears possess unique lipid profiles and specialized proteins that manage cholesterol and prevent cellular damage in extreme cold. They are, in a very literal sense, chemically armored against the frost. Their morphology has also shifted to meet the demands of a liquid world. Their paws are massive, acting as dual-purpose tools. They are wide, snowshoe-like platforms that distribute weight across thin ice to prevent breaking through, and they are equipped with specialized, water-repellent fur between the pads to provide traction and insulation during long-distance swims. Even the texture of their paw pads has evolved, featuring small dermal bumps called papillae, which provide the grip necessary to navigate the slick, treacherous surfaces of pressure ridges. Every aspect of their existence is an exercise in extreme efficiency. From the specialized olfactory bulb in their brain, capable of detecting a seal's breathing hole through meters of solid ice and snow, to the metabolic pathways that allow them to switch between burning carbohydrates and pure fat, the polar bear is a biological marvel. They are the result of an evolutionary arms race against the most hostile environment on Earth. They have mastered the geometry of the ice, the chemistry of the cold, and the physics of the sea. They are the apex of specialization, a predator so perfectly adapted to a world of ice and salt that they have become inseparable from it. But in the natural world, there is a dangerous side to perfection. Extreme specialization leaves no room for error. When the environment that shaped you begins to dissolve, your greatest strengths can quickly become your most profound vulnerabilities. But how does a predator find its way through a landscape that is essentially a featureless, blinding expanse of white? In the Arctic, sight is often a secondary luxury. The sun reflects off the snow with a blinding intensity, creating a world of glare and deceptive shadows where distance and depth are easily lost. To conquer this void, the polar bear has evolved a sensory suite that defies the limitations of the frozen terrain. They do not merely see the Arctic. They perceive it through a multidimensional map of chemical and tactile signals. At the heart of this mastery is the most sophisticated olfactory system in the mammalian kingdom. While a human sense of smell is a tool for identification, a polar bear's sense of smell is a long-range radar. Their olfactory bulbs are disproportionately large, wired into a brain that can process scent molecules with surgical precision. A polar bear can detect the scent of a ringed seal from over a kilometer away, even when that seal is hidden beneath meters of packed snow or thick ice. This is not just a detection of meat. It is the ability to distinguish between the subtle chemical signatures of life and the inanimate cold. They can sense the specific scent of a seal's breath escaping through a microscopic breathing hole, a tiny crack in the ice that is invisible to the naked eye. To a bear, that scent is a beacon, a thermal and chemical trail that cuts through the howling winds of a blizzard. Yet the scent is only the beginning of the hunt. Once the bear has located its target, the hunt shifts from the chemical to the tactile. This is where the bear's stealth becomes a masterpiece of physics. A polar bear does not simply walk, it navigates the micro-textures of the ice. As we noted, their paws are equipped with dermal papillae, but their sensitivity extends deeper. They can feel the subtle vibrations of movement through the ice. The slight shift of a seal's weight or the rhythmic pulse of a creature swimming just beneath the flow. They are masters of the still hunt, a high-stakes game of patience. A bear may sit motionless for hours, becoming a literal extension of the ice, waiting for the exact moment the sensory data aligns. They utilize a technique known as still hunting, where they lie in wait by a breathing hole, their entire nervous system tuned to the slightest change in air pressure or scent concentration. They are waiting for that singular, microscopic moment of vulnerability. Even their hearing is specialized for the acoustics of the ice. In the Arctic, sound travels differently. The ice acts as a massive, frozen sounding board. A polar bear can pick up the low-frequency thuds of shifting ice or the distant splash of a predator, allowing them to map the structural integrity of their world. They know where the ice is thick enough to support their weight and where it is thin enough to shatter. This sensory integration, smell, touch, and sound, creates a unified field of awareness. The polar bear lives in a world of invisible threads, a web of scents and vibrations that connects the hunter to the hunted. They are the ultimate sensory specialists, capable of extracting life-sustaining information from a landscape that, to any other creature, appears empty and silent. But this hyperspecialization is a double-edged sword. Their senses are tuned to a very specific frequency, the frequency of the ice. As that ice begins to crack, melt, and vanish, the very signals they rely on to survive are beginning to fade into the noise of a changing world. But finding the prey is only half the battle. The true challenge lies in the brutal mathematics of survival. In the Arctic, life is not measured in miles or days, but in calories. To exist in a realm of perpetual frost, the polar bear must participate in one of the most extreme energy economies on Earth, a high-stakes biological ledger where every movement must yield a profit, or it leads toward bankruptcy. This is not a world of grazing or foraging. A polar bear cannot sustain its massive, multi-hundred-kilogram frame on berries, vegetation, or even the occasional scavenging of a carcass. To fuel a body designed for thermoregulation in sub-zero temperatures, they require a very specific, high-octane fuel, lipid-dense blubber. The polar bear is effectively a specialist in the consumption of fat. Their primary targets, the ringed and bearded seals, are biological storage tanks, packed with layers of thick, calorie-rich adipose tissue. When a bear successfully hunts, it isn't looking for the meat, the protein, as much as it is looking for the oil. In fact, a bear can undergo a process of selective feeding, where it consumes only the energy-dense blubber of a seal, leaving the leaner muscle behind. This is a strategic choice driven by metabolic necessity. Protein, while essential, requires significant metabolic energy to process. In a state of fasting, digesting too much protein can actually lead to rabbit starvation, a condition where the body begins to consume its own tissues to manage the nitrogenous waste. To avoid this, the bear must prioritize the liquid gold of seal fat. This reliance on fat creates a hyper-specialized metabolic state. Polar bears have evolved a unique ability to manage massive fluctuations in body mass. They can transition between periods of intense hyperphagia, the state of excessive eating during the spring seal pupping season, and long periods of fasting. During these lean months, they enter a state of walking hibernation. Unlike true hibernators that sleep in dens, the polar bear remains active, but its metabolism slows, its heart rate drops, and its body begins to burn through its own stored fat reserves with incredible efficiency. This efficiency is a masterpiece of evolutionary engineering. They can maintain their core temperature and even support the high energy demands of pregnancy and nursing, all while their body is essentially digesting itself from the inside out. They are masters of recycling their own energy, turning stored lipids into the very fuel that keeps their blood warm and their muscles moving. However, this specialized economy is built upon a foundation of extreme predictability. The entire system relies on a synchronized cycle. The ice must be thick enough to hunt, the seals must be present to provide the fat, and the timing must allow the bear to build a massive caloric bank account before the summer melt. The bear is essentially a biological investor, and the ice is its marketplace. In this economy, fat is the currency, and the ice is the bank. But as we will see, the bank is beginning to crumble, and the currency is becoming harder and harder to find. When the seasonal windows of opportunity shrink, the bear is left with a mounting deficit that no amount of evolutionary ingenuity can balance. What happens to a masterpiece of engineering when the very stage it performs on begins to dissolve? To understand the gravity of the situation, we must look closer at the delicate architecture of this Arctic relationship, a phenomenon ecologists call a trophic coupling. This isn't just a simple case of predator and prey. It is a perfectly synchronized biological dance where every participant moves to the rhythm of the frozen sea. The equilibrium is maintained by a series of invisible, razor-thin margins. At the base of this pyramid, the sea ice acts as the primary platform for life. It is more than just a floor, it is a nursery. Beneath the ice, microscopic algae grow in the brine channels, fueling a bloom of zooplankton that feeds the Arctic cod. These fish, in turn, sustain the ringed seals, which are the primary architects of the polar bear's caloric wealth. This is a closed-loop system of extreme precision. The ringed seal requires stable, multi-year ice to construct its subnivean layers, the snow-covered tunnels where it gives birth to pups. These pups are the interest in the bear's caloric bank account. Without the specific density of snow and the structural integrity of the ice, the seal pups are exposed to the elements and predators, causing the population to plummet. If the seal population falters, the bear's investment strategy fails before the season even begins. This equilibrium is also governed by a phenomenon known as phenological synchrony. In the Arctic, timing is everything. The spring thaw and the autumn freeze must occur at specific, predictable intervals to allow for the feast and the fast. The polar bear's life cycle is hard-coded into these seasonal cues. They have evolved to arrive at the breathing holes of seals exactly when the seal pups are most vulnerable and the ice is at its most stable. This is a biological handshake between two species that has remained unchanged for millennia. But there is a hidden complexity to this balance, the concept of energy flux. In a healthy Arctic, the energy flows upward from the sun, through the algae, through the fish, through the seals, and finally into the bear. This flow is regulated by the temperature of the water and the thickness of the ice. For thousands of years, this flux has been stable. The bear has been able to predict exactly how much liquid gold it could harvest each year, allowing it to plan its reproductive cycles and its periods of walking hibernation with mathematical certainty. However, a system this finely tuned is also inherently brittle. In ecology, the more specialized a species becomes, the more vulnerable it is to regime shifts, sudden, fundamental changes in the environment that rewrite the rules of survival. The polar bear is the ultimate specialist. It has traded the flexibility of a generalist for the extreme efficiency of a high-fat predator. This specialization is its greatest strength, but it is also its fatal flaw. The equilibrium is not a static state of rest. It is a dynamic, vibrating tension held together by the predictable arrival of the ice. When that predictability vanishes, the dance breaks. The synchronization is lost. The handshake is missed. And when the rhythm of the Arctic changes, the bear is left trying to play a masterpiece on an instrument that is literally breaking apart. But how do we define a creature that is both a god and a phantom? To the indigenous peoples of the Arctic, the bear is not merely an animal. It is a spiritual entity, a bridge between the terrestrial and the divine. In Inuktitut, the bear is often spoken of with a reverence that borders on the sacred. They are the masters of the threshold, existing in the liminal space between land and sea, between the visible world and the white void. To encounter a polar bear in the wild is to encounter a presence that feels less like biology and more like an ancient, watchful spirit. They are the ghost of the north, a silhouette emerging from a blizzard, a shape that seems to manifest from the snow itself. This spectral quality is not just a matter of folklore, it is rooted in a profound biological reality. The polar bear possesses a unique form of camouflage that defies traditional optics. Their fur is not actually white. It is composed of pigment-free, translucent, hollow hair shafts. These tubes act as fiber optics, channeling UV light down toward their skin, which is as black as coal to absorb every possible photon of solar heat. When a bear moves through a whiteout, it doesn't just blend in, it becomes part of the light itself. They are optical illusions, designed by evolution to be invisible until the moment of impact. This invisibility extends to their sensory world. A polar bear can detect the scent of a seal through 3 feet of solid ice and from over a mile away. This olfactory capability is so precise that it allows them to see through the frozen crust of the world, locating life that is hidden from every other sense. They navigate a landscape of silence and shadow, moving with a ghostly stealth that belies their massive, 1,000-pound frames. Yet this spiritual and biological majesty carries a heavy weight of symbolism. For centuries, the bear has stood as the ultimate symbol of Arctic resilience, an apex predator that conquered the most inhospitable environment on Earth. They represent the triumph of life over absolute zero. In many northern cultures, the bear is a teacher, a symbol of strength, and a guardian of the seasonal cycles. Their presence is the heartbeat of the North. Their absence would signal a fundamental silence in the rhythm of the world. But there is a growing, haunting irony in their title. A ghost is a memory of something that once was, a lingering trace of a presence that has departed. As we observe the fracturing of the ice and the shifting of the thermal currents, the ghost of the North begins to take on a more literal, tragic meaning. We are witnessing the slow transition of the polar bear from a living, breathing sovereign of the ice to a mere specter of a lost era. The very traits that made them the undisputed masters of the Arctic, their extreme specialization, their translucent camouflage, their reliance on the predictability of the freeze, are the very things that are turning them into shadows. As the stage dissolves, the performer does not just struggle, they begin to fade. The question we must face is whether we are watching a living masterpiece in its prime, or if we are merely witnessing the final, fading echoes of a ghost. If the polar bear is the performer on this frozen stage, then we must ask, why is the stage itself melting away at a rate that defies the laws of the rest of the world? To understand the tragedy of the bear, we must look beyond the simple rise in global temperatures and confront a phenomenon known as Arctic amplification. While the world at large feels the slow, creeping warmth of a changing climate, the Arctic is not merely warming, it is screaming. It is heating up at nearly 4 times the global average. This is not a localized weather pattern, nor is it a simple seasonal shift. It is a systemic, runaway acceleration, a phenomenon where the North Pole acts as a magnifying glass for the sun's heat. To grasp the scale of this, we have to look at the physics of the surface. For millennia, the Arctic has functioned as the planet's air conditioner. This was made possible by a principle known as the Albedo Effect. In a healthy Arctic, the landscape is a vast, unbroken mirror of white ice and snow. This high albedo surface reflects up to 85% of the incoming solar radiation back into space, keeping the region, and by extension, the entire planet, cool and stable. But we have entered a dangerous feedback loop. As the atmosphere warms, the ice begins to fracture and melt. Where there was once a reflective white mirror, there is now dark open ocean. Unlike ice, the dark sea is an absorber. It doesn't reflect the sun, it swallows it. The ocean absorbs roughly 90% of the solar energy that hits it, turning that light into thermal energy. This warms the water, which in turn melts more ice from below, exposing more dark ocean, which absorbs more heat. It is a self-reinforcing cycle, a thermodynamic spiral that feeds on its own destruction. This is the engine of Arctic amplification. It is a process that turns a linear increase in greenhouse gases into an exponential catastrophe in the north. But the amplification goes deeper than just the surface. There is a hidden, atmospheric mechanism at play as well. As the temperature gradient between the warming Arctic and the temperate mid-latitudes narrows, the jet stream, the high-altitude river of air that dictates global weather patterns, begins to weaken and wobble. This waviness allows warm, moist air from the south to penetrate deeper into the polar circle, bringing unseasonable rains that don't just melt the snow, but actually darken it with soot and dust, further lowering its albedo and accelerating the thaw. We are seeing a fundamental reorganization of the planet's heat distribution. The Arctic is no longer a heat sink, it is becoming a heat source. The very thermal buffer that protected the polar bear's kingdom for eons is being dismantled by the very energy it once deflected. For the bear, this isn't an abstract scientific concept or a data point on a graph. It is the literal disintegration of their reality. The magnifying glass of the Arctic is no longer reflecting the sun away. It is focusing the heat directly onto the thin, fragile crust of ice upon which their entire existence depends. The stage isn't just getting warmer, the stage is being consumed by the light. What if I told you that the very light that gives life to our world is, in the Arctic, becoming a weapon of destruction? To understand why the ice is vanishing so much faster than our models once predicted, we have to look at a silent, invisible thief, the loss of reflectivity. In physics, this is the Albedo Effect, the measure of how much solar energy a surface reflects versus how much it absorbs. For most of human history, the Arctic has been the Earth's ultimate shield. A vast, crystalline expanse of snow and sea ice possessing an incredibly high albedo. It was a planetary mirror, bouncing the sun's fury back into the vacuum of space, acting as a thermal regulator that kept the entire Earth's climate in a state of predictable equilibrium. But we are witnessing a fundamental and terrifying phase shift in the planet's chemistry. As the first cracks of warmth appear, the mirror begins to shatter. When white ice melts, it reveals the deep, abyssal blue of the Arctic Ocean beneath. This is the moment the trap is sprung. While ice reflects the majority of solar radiation, the open ocean is a thermal sponge. It possesses a low albedo, meaning it absorbs the vast majority of the sun's energy. This creates a phenomenon known as a positive feedback loop, a term that sounds clinical in a laboratory, but in the Arctic, it is a death spiral. The more ice melts, the more dark water is exposed. The more dark water is exposed, the more heat the ocean absorbs. The more heat the ocean absorbs, the more ice melts from beneath. It is a self-perpetuating engine of warming that requires no further input from human carbon emissions to keep moving. It has become a runaway machine, fueled by its own destruction. But there is a more insidious layer to this transition that many overlook: the change in the quality of the ice itself. It isn't just the quantity of ice that is failing, but its composition. As the Arctic warms, we are seeing a shift from multi-year ice, thick, ancient, highly reflective ice that has survived many summers, to first-year ice, which is much thinner, saltier, and more prone to rapid melting. This newer, thinner ice lacks the structural integrity and the reflective purity of its predecessor. It is a weaker shield, a dimmer mirror. Furthermore, we must consider the darkening of the Arctic. As the ice recedes, it isn't just replaced by water. It is often coated in a fine layer of black carbon, soot from distant industrial fires and shipping lanes. This microscopic dust settles on the snow, lowering the albedo even further. Even a thin dusting of dark particles can cause the ice to absorb significantly more heat, turning a pristine white surface into a dark, heat-absorbing crust. This is the physics of a disappearing world. The Arctic is losing its ability to defend itself. The thermal barrier that once insulated the polar bear's kingdom is being replaced by a dark, hungry ocean that seeks only to drink more heat. We are not just witnessing the melting of ice, we are witnessing the collapse of the planet's most vital cooling mechanism. The mirror is breaking, and as it falls, the heat is rushing in to fill the void. If the melting ice is the breaking mirror, then the ocean beneath is the engine that is driving the shards further apart. We have spoken of the surface, the visible tragedy of the disappearing white expanse. But to truly grasp the scale of this transformation, we must dive deeper, beneath the waves, into the great, churning arteries of the planet, the ocean currents. For millennia, the Arctic has not been a stagnant pool of ice, but a dynamic participant in a global circulatory system. It is part of the thermohaline circulation, often called the global ocean conveyor belt, a massive, slow-moving loop driven by differences in temperature and salinity. In a healthy Arctic, cold, dense, salty water sinks toward the ocean floor, pulling warmer currents from the tropics northward to replace it. This rhythmic pulse is what maintains the predictable seasonal cycles that polar bears have relied upon for evolutionary epochs. But that pulse is faltering. As the ice melts at an unprecedented rate, it is not just releasing water. It is releasing a massive, sudden influx of fresh water into the saline environment of the north. This is a phenomenon known as freshening. Unlike saltwater, which is dense and sinks, freshwater is buoyant. It sits on the surface like an insulating cap, a layer of liquid lightness that refuses to descend. This layer acts as a lid, effectively choking the vertical movement of the ocean. By disrupting the sinking of cold, salty water, we are essentially putting a wrench into the gears of the conveyor belt. But the danger isn't just in what is being added, it is in what is being redirected. We are seeing a terrifying shift in how heat is transported into the Arctic basin. Traditionally, the Arctic was protected by a barrier of cold water. Now, as the circulation patterns shift, we are witnessing the Atlantification of the Arctic Ocean. Warm, nutrient-rich waters from the Atlantic are pushing deeper and further north than ever before. This isn't just a change in temperature, it is a structural invasion. This Atlantic water is warmer and much more saline than the native Arctic waters. It acts like a thermal battering ram, attacking the ice from below. While the sun attacks the ice from above, these encroaching currents melt it from the bottom up, eroding the very foundation of the sea ice platform. This creates a dual-front war for the ice. It is being attacked by the light of the sun and the heat of the currents simultaneously. This basal melting is particularly devastating because it targets the thickest, most stable parts of the ice, the very ice that polar bears need to hunt, to travel, and to raise their young. Furthermore, these changing currents are altering the biological landscape. The shifting temperatures and salinity levels are rearranging the microscopic life at the base of the food web. Phytoplankton and zooplankton, the tiny engines of Arctic life, are being displaced or forced to migrate, triggering a trophic cascade that ripples upward, from the smallest crustacean to the ringed seals, and ultimately to the apex predator. The currents are no longer the predictable guardians of the Arctic's cold. They have become the harbingers of its warmth. The ocean is no longer just a stage for the polar bear's life. It has become an unpredictable, warming force that is actively dismantling the architecture of its world. But what if the very ground the bears walk upon is as transient as the ice they hunt upon? To understand the instability of the Arctic, we must look away from the shifting currents of the sea and toward the frozen foundations of the land. Beneath the tundra, a silent, ancient giant is waking up. This is the permafrost, a subterranean layer of soil, rock, and organic matter that has remained frozen for tens of thousands of years. It is not merely cold dirt. It is a massive, frozen vault, a geological anchor that has held the Arctic landscape in a state of rigid permanence since the last ice age. For the polar bear, the permafrost is the stage upon which the terrestrial part of their lives plays out. It provides the stability for the coastal cliffs where they may rest, the solid ground for their denning sites, and the structural integrity of the islands they traverse. But as the atmospheric warmth we have discussed begins to penetrate the Earth, this vault is being pried open. The thawing of permafrost is not a uniform process. It is a violent, structural disintegration. As the ice within the soil melts, the ground loses its cohesive strength. This leads to a phenomenon known as thermokarst, a landscape of sudden collapses, sinkholes, and slumping hillsides. Entire coastlines, once thought to be immutable, are literally dissolving into the sea. This coastal erosion is accelerating at rates that defy previous climate models, stripping away the buffer between the land and the warming ocean. For a species that relies on stable shorelines to navigate and rest, the very geography of their world is becoming fluid and unpredictable. However, the most insidious danger of the disappearing permafrost is not what we can see, but what we cannot. Deep within this frozen soil lies a massive reservoir of ancient biological secrets, vast quantities of organic carbon trapped in the remains of plants and animals that died millennia ago. As the thaw progresses, microbes are being reawakened. They begin to feast on this long-dormant organic matter, and in the process, they release gases as a byproduct of their digestion. This is the permafrost carbon feedback loop, one of the most terrifying tipping points in climate science. The microbes release carbon dioxide and, even more potently, methane, a greenhouse gas that is over 80 times more effective at trapping heat than CO2 over a 20-year period. This creates a catastrophic cycle. The warming thaws the permafrost, the thawing permafrost releases methane, and the methane accelerates the warming, which in turn thaws more permafrost. It is a self-sustaining engine of heat that, once fully engaged, becomes nearly impossible for human intervention to stop. We are witnessing a profound geological betrayal. The ground, which for eons served as a stabilizer for the Arctic ecosystem, has transformed into a source of instability. The melting permafrost is not just changing the shape of the coast, it is fundamentally altering the chemistry of our atmosphere. As the land softens and the ancient gases escape, the Arctic is losing its ability to act as a stabilizer for the planet. The foundation is failing. The stage is crumbling. And as the terrestrial world shifts beneath them, the polar bear finds itself standing on a landscape that is no longer a home, but a dissolving memory. But if the very ground beneath them is dissolving, what happens when the rhythm of the seasons, the heartbeat of the Arctic, begins to skip? For millennia, the Arctic has operated on a clock of crystalline precision. There was a time when the transition from the long, dark winter to the brief, sun-drenched summer was a predictable, cyclical dance. This rhythm was the polar bear's lifeline. The seasons weren't just changes in temperature. They were a biological schedule, a series of cues that dictated when to hunt, when to migrate, and when to breed. But today, that clock is breaking. We are no longer seeing a simple warming. We are witnessing a fundamental temporal distortion. The Arctic is experiencing a phenomenon known as seasonal advancement. Spring is arriving earlier, and autumn is arriving later, but they are not arriving in a way that benefits the life within them. Instead, the traditional windows of opportunity are being squeezed, compressed by a climate that no longer respects the ancient boundaries of the calendar. The most critical casualty of this shift is the ice-on and ice-off period. To a polar bear, The arrival of sea ice is the signal to begin the most important phase of their year, the hyperphagic period. This is a window of intense, high-calorie feeding where they must consume enough seal blubber to sustain them through the lean months. Historically, the ice would form early enough in the autumn to allow for a long, stable hunting season. But the seasons are shifting the goalposts. The autumn freeze-up is occurring later and later each year. This delay creates a phenological mismatch, a scientific term for a tragic biological error. It occurs when the timing of a predator's needs no longer aligns with the availability of its prey. The seals are following their own biological cues, often pupping or moving according to water temperature and light cycles, but the sea ice, the platform the bear requires to reach them, is not there to meet them. The bear is ready to hunt, but the stage has not been set. Furthermore, the very duration of the fasting season is being radically altered. In a stable Arctic, the summer melt was a predictable period of waiting. Now, the summer melt period is stretching, encroaching upon the autumn. This means the bears are being forced to endure longer periods of nutritional deprivation before the ice even returns. They are being caught in a physiological pincer movement. They are losing time at the beginning of the season and losing time at the end. This isn't just a delay in weather. It is a disruption of biological synchronicity. Even the light itself is changing the math of survival. As the Arctic experiences more extreme weather events, unseasonal rain in the middle of winter or sudden heat waves in the spring, the snowpack, which is vital for denning, becomes unstable. A rain-on-snow event can turn a soft, insulating den into a frozen, suffocating tomb of ice. The seasons used to be a predictable cycle of abundance and rest. Now, they have become a chaotic scramble. The predictable pulse of the north is being replaced by a jagged, erratic tempo. For the polar bear, living by the seasons once meant knowing when to fight and when to wait. Now, they are fighting a clock that is spinning out of control, chasing a winter that arrives too late and fleeing a summer that refuses to leave. But how can a creature so perfectly adapted to the extreme survive a threat it cannot see, smell, or fight? While the melting ice is a visible catastrophe, there is a more insidious, silent killer drifting through the Arctic currents, a ghost in the machine of the ecosystem. We often think of the Arctic as a pristine, untouched fortress, but it has become a global sink for the invisible byproducts of human civilization. This is the phenomenon of long-range atmospheric transport. Every year, millions of tons of carbon, heavy metals, and persistent organic pollutants are released from factories, vehicles, and industrial agriculture in temperate zones thousands of miles away. These toxins don't simply dissipate. They hitch a ride on global wind currents and ocean streams, traveling north until they reach the poles. Through a process known as global distillation, or the grasshopper effect, these chemicals evaporate in warmer climates, migrate through the atmosphere, and then condense and settle in the cold Arctic air. The North Pole is effectively acting as a chemical trap, collecting the world's waste in a place where nothing is meant to accumulate. Once these substances land on the ice and sea, they enter the base of the food web. It begins with microscopic phytoplankton and zooplankton, absorbing trace amounts of toxins like PCBs, polychlorinated biphenyls, and heavy metals like mercury. But then, a terrifying biological process takes over: biomagnification. As a small fish eats thousands of plankton, it concentrates those toxins in its tissues. A seal, eating hundreds of those fish, absorbs a much higher, more concentrated dose. By the time these toxins reach the apex predator, the polar bear, the concentration has magnified exponentially. For a polar bear, the very thing that keeps them alive, the thick, energy-dense blubber of a seal, is also the very thing that delivers a lethal dose of concentrated poison. This is the invisible betrayal of the Arctic food web. The bear's greatest biological advantage has been turned into a delivery system for industrial toxins. These chemicals are lipophilic, meaning they are fat-seeking. They hide within the bear's massive energy reserves, lying dormant during periods of plenty, only to be released into the bloodstream during the lean months of fasting. As the bear burns its fat to survive the hunger gap, it is simultaneously flooding its own system with a concentrated surge of toxins. The consequences are not immediate, but they are profound and systemic. These pollutants act as endocrine disruptors, silently sabotaging the bear's internal chemistry. They interfere with hormone signaling, which can impair reproductive success, weaken immune responses, and even alter neurological development in cubs. A bear may appear physically robust, yet internally, its ability to sustain life is being eroded from the inside out. The bear is fighting a war on two fronts. On one side, the physical world is dissolving beneath its paws as the ice vanishes. On the other, its very biology is being compromised by a chemical tide rising from the south. It is a dual assault, one of heat and one of chemistry. The bear is being squeezed by a changing climate and poisoned by a changing world, facing a threat that is as pervasive as it is invisible. But how does a body designed for abundance survive a reality of nothingness? To understand the polar bear's struggle, we must first understand the biological miracle of their metabolism. The polar bear is not merely a predator. It is a living battery. Throughout the spring, when the sea ice is most stable, these bears engage in a period of hyperphagia, an intense feeding frenzy. They gorge on seal blubber, consuming upwards of 2 million calories in a single season, storing this energy not as muscle, but as a massive, insulating layer of adipose tissue. This fat is their life insurance. It is their fuel, their warmth, and their survival kit for the months when the world turns barren. Under normal circumstances, the fasting season is a predictable, rhythmic part of the Arctic cycle. As the summer sun arrives and the ice retreats, the bears are forced onto land, away from their primary food source, the ringed seal. During this period, the bear enters a state of walking hibernation. Unlike true hibernators, such as ground squirrels, polar bears remain active, but their internal chemistry undergoes a radical shift. Their metabolic rate drops, and their bodies begin the slow, grueling process of catabolism, breaking down their own stored fat to sustain vital organ function. But the rhythm is breaking. Because of the warming Arctic, the window of opportunity to hunt is shrinking, while the duration of the fast is stretching. We are witnessing a catastrophic expansion of the hunger gap. In years past, a bear might fast for several months. Now, they are being pushed to endure months beyond their physiological limit. There is a threshold in a bear's biology that we are only beginning to understand, the point of metabolic exhaustion. As the fat stores dwindle, the body begins to look for other fuel sources. It starts to scavenge its own muscle tissue. This is a desperate, secondary stage of starvation. The bear begins to consume its own protein to maintain blood glucose levels, leading to a rapid decline in physical strength. This creates a lethal feedback loop. A bear that has lost significant muscle mass is a bear that cannot hunt effectively, cannot swim long distances, and cannot defend its territory. Furthermore, we must consider the energetic cost of movement. In a healthy Arctic, a bear moves across stable ice to find food. In the modern Arctic, the ice is fragmented, drifting further apart. This forces the bear into long-distance swims that can last for days. Every kilometer swum is a massive caloric expenditure. When a bear is already in a state of fasting, these swims are not just difficult, they are mathematically impossible to sustain. They are burning more energy than they could ever hope to find on the distant, melting floes. This is the biological toll of a changing climate. It is a slow, quiet attrition. It isn't just about the absence of food. It is about the terrifying math of energy expenditure versus energy intake. As the fasting season lengthens, the bear's body is being forced to cannibalize itself, turning its very strength into the fuel for its own decline. The battery is running dry, and in the vast, empty expanse of the changing north, there is no way to recharge. What happens when the math of survival no longer adds up? To understand the tragedy of the polar bear, we must look past the visible hunger and into the invisible, microscopic battle occurring within their very cells. It is a battle of thermodynamics, where the laws of physics are becoming a death sentence. We call this the energy deficit, a widening chasm between the calories a bear requires to function and the calories it can realistically acquire. In a stable ecosystem, the polar bear operates on a surplus. But as the ice melts earlier and freezes later, the bear is being forced into a state of chronic metabolic bankruptcy. We often think of starvation as a simple lack of food, but for a marine mammal of this scale, starvation is an active, aggressive process of self-destruction. As the adipose tissue, that vital layer of life insurance we discussed, reaches a critical low, a phenomenon known as metabolic switching occurs. Normally, the bear's body is a master of lipid metabolism, efficiently burning fat to power the heart, the brain, and the lungs. But as those fat stores vanish, the body enters a state of desperation. It begins a process called gluconeogenesis, a frantic, internal scavenging mission where the body breaks down its own skeletal muscle to create the glucose necessary to prevent brain failure. This is the true horror of the deficit. The bear is literally consuming its own engine to keep the lights on. Every stride taken across a crumbling ice floe, every desperate attempt to reach a distant shore, requires muscle. But that muscle is being diverted to fuel the heart. The more the bear moves to find food, the more it destroys the very machinery it needs to hunt. It is a biological paradox. The effort required to survive is precisely what is accelerating its demise. This deficit is further compounded by a phenomenon known as thermal cost. A polar bear's massive size is an evolutionary masterpiece designed to retain heat in sub-zero temperatures. However, as the Arctic warms and the ice becomes fragmented, bears are forced into the water more frequently. Water conducts heat away from the body 25 times faster than air. For a bear in a state of energy deficit, a long-distance swim is not merely a test of endurance, it is a massive thermal drain. They are losing heat at an exponential rate, forcing their metabolism to work even harder to maintain core temperature, which in turn burns through their dwindling glucose reserves even faster. We are also seeing the impact of nutritional density. As the traditional hunting grounds shift, bears are increasingly forced to scavenge for suboptimal prey, bird eggs, berries, or even kelp. While these may provide calories, they lack the hyper-concentrated lipid content of seal blubber. It is the difference between eating a feast and eating scraps. You can fill your stomach with scraps, but you cannot fill your biological battery with them. The energy deficit is not just a period of being hungry, it is a systemic collapse of the bear's internal economy. The math of the Arctic has turned hostile. When the energy required to find the next meal exceeds the caloric value of the meal itself, the bear enters a state of physiological insolvency. It is a race against a clock that is ticking faster every year, a race where the finish line is not a feast, but total metabolic exhaustion. But what happens when the search for a feast turns into a desperate scavenger hunt through a landscape that no longer offers any rewards? As the caloric bankruptcy we just discussed reaches its breaking point, the polar bear is forced into what biologists call the foraging crisis. This is not merely a change in diet, it is a fundamental breakdown of a specialized evolutionary strategy. For hundreds of thousands of years, the polar bear has been a highly tuned biological machine, a specialist designed for one thing and one thing only: the extraction of massive amounts of lipids from ringed and bearded seals. They are not generalists. They are not designed to be opportunists. they are designed to be masters of a very specific, very high-octane fuel source. Yet, as the sea ice, their primary hunting platform, retreats into the deep Arctic basin, the specialized tools of the predator are rendered useless. The bear can no longer sit at a breathing hole and wait for the high-fat prize. Instead, it is forced into a state of ecological desperation, attempting to substitute the gold standard of seal blubber with what can only be described as biological junk food. We see them increasingly raiding the nests of colonial seabirds, consuming eggs and chicks. While this provides a temporary influx of protein, it is a metabolic trap. Protein is essential for tissue repair, but it cannot be efficiently converted into the massive adipose reserves required to survive the Arctic summer. To burn protein for energy, the bear's liver must undergo a process called urea production, which requires significant water and metabolic energy. In a sense, the bear is working harder to process the food than the food is worth. They turn to terrestrial sources, berries, kelp, and even vegetation. While these items provide carbohydrates, they are a drop in the ocean compared to the thousands of calories found in a single seal carcass. A polar bear would need to consume hundreds of pounds of vegetation to equal the energy density of a single seal. In the vast, frozen expanse of the Arctic, such a feat is physically impossible. Perhaps most concerning is the emergence of trophic mismatch. As the Arctic warms, the timing of biological events is shifting. The seasonal pulses of life, the migration of birds, the blooming of plants, the movement of fish, are no longer synchronized with the bear's traditional hunting windows. The bear is arriving at its foraging grounds only to find the menu has already changed. Even more insidious is the shift in prey availability due to borealization, the northward movement of subarctic species. As warmer waters move in, new species of fish and invertebrates enter the Arctic ecosystem. While this increases biodiversity, it creates a nutritional void for the bear. These new species lack the specific fatty acid profiles, such as omega-3 long-chain polyunsaturated fatty acids, that the polar bear's endocrine and nervous systems have evolved to require. The foraging crisis is, therefore, a crisis of quality, not just quantity. The bear is no longer a hunter. It is becoming a scavenger in a world that offers only crumbs. It is a hollow existence, a cycle of searching, finding, and consuming, only to realize that the fuel it has gathered is insufficient to keep the engine running. The specialized predator is being forced to live a generalist's life, and in the unforgiving math of the Arctic, a generalist cannot survive the winter. Can a creature built for greatness survive on nothing but its own shadow? As the caloric bankruptcy reaches its breaking point, the physical manifestation of this struggle becomes visible in a way that is both haunting and undeniable: the systemic decline of body mass. To the casual observer, a polar bear is a symbol of sheer, overwhelming power. But beneath the white fur, a silent, microscopic war is being lost. The bear is quite literally consuming itself. Biologists tracking these apex predators are witnessing a trend that defies the traditional understanding of animal aging. We aren't just seeing thin bears, we are seeing a fundamental shrinking of the species' physical stature. In several subpopulations, particularly in the western Hudson Bay, the average weight of adult males has plummeted. This isn't just a seasonal fluctuation. It is a downward trajectory of the species' biological baseline. To understand why this is so catastrophic, we have to look at the bear's unique physiology. A healthy polar bear is essentially a walking reservoir of lipids. This subcutaneous fat layer serves a dual purpose. It is a critical thermal insulator against the sub-zero Arctic winds, and it is a metabolic battery. When a bear enters its fasting period, it doesn't just lose weight. It enters a state of physiological dormancy, where it relies on the slow, controlled oxidation of these fat stores. However, as the hunting season shrinks, the battery is never fully charged. This creates a phenomenon known as compounding metabolic debt. When a bear starts its summer fast with insufficient adipose reserves, it doesn't just tap into its fat, it begins to undergo autophagy, a process where the body begins to break down its own functional tissues to maintain blood glucose levels. It begins to digest its own muscle mass. The very engines of movement, the massive pectoral and limb muscles required to swim kilometers of open water, are being harvested by the body to keep the heart beating and the brain functioning. This leads to a terrifying biological feedback loop. As the bear loses muscle mass, its locomotive efficiency drops. It becomes slower, less agile, and less capable of the explosive bursts of speed required to ambush a seal. A weaker bear is a less successful hunter. A less successful hunter is a thinner bear. The spiral is relentless. Furthermore, we are seeing the impact on the condition index, a scientific metric used to determine the relationship between a bear's mass and its length. In a stable ecosystem, a bear's length and weight grow in tandem. But in the warming Arctic, we are seeing stunted growth patterns. Even the bears that reach adulthood are doing so with significantly lower body mass than their ancestors did just 3 decades ago. This decline is most devastatingly felt in the transition from fat to muscle loss. When a bear loses its fat, it can recover. But once the body begins the heavy lifting of catabolizing muscle tissue, the damage often becomes irreversible. The bear becomes a ghost of its evolutionary design, a hollowed-out version of a predator that was once the undisputed master of the ice. We are witnessing the slow, visible erosion of an icon. The polar bear is not just losing its habitat, it is losing its very substance, fading away 1 calorie at a time. But what happens when the ice beneath their paws doesn't just melt, but retreats? When the frozen highway of the Arctic fractures into a mosaic of isolated flows, the bear is faced with a choice that defies its very biology: stay and starve, or swim and gamble everything. For most, the choice is to move. But the distance between these islands of ice is growing at an unprecedented rate. What was once a short hop across a frozen bridge has become a desperate marathon odyssey through the open, dark expanse of the Arctic Ocean. To understand the sheer extremity of this feat, we must look at the physics of the swim. A polar bear is an apex predator, but it is not a fish. It is a heavy, high-density mammal. To move through water, a bear must fight against immense drag, pushing a massive, non-hydrodynamic body through a medium that is constantly trying to sap its heat. This is where the compounding metabolic debt we discussed becomes a death sentence. Every stroke of a paw is a withdrawal from a bank account that is already overdrawn. In a healthy bear, a long swim is a calculated expenditure of stored lipids. But for a bear undergoing autophagy, a bear that is already digesting its own muscle to stay alive, the cost of movement is catastrophic. They are not just swimming through water. They are swimming through a thermal vacuum that pulls the remaining warmth from their depleted bodies. We are now documenting extreme long-distance swimming events that were virtually unheard of in previous decades. There are recorded instances of bears swimming continuously for over 9 days, covering hundreds of miles of open ocean without a single moment of rest. Imagine, for a moment, the physiological toll of such an endeavor. Without the ability to haul themselves out of the water to rest and thermoregulate, their heart rates must remain elevated, and their metabolic rate stays pinned at a level their starving bodies simply cannot sustain. There is a terrifying biological phenomenon at play here, the threshold of exhaustion. When a bear reaches this point, its ability to maintain buoyancy and directionality collapses. As the muscles fatigue, the bear's stroke becomes shallow. Its head, once held high above the swell, begins to dip. In these moments, the bear is no longer a hunter. It is a victim of its own evolutionary specialization. Their thick, insulating fur, while magnificent on land or in a short dip, becomes a heavy, waterlogged burden during a multi-day swim. The very weight that protects them from the cold becomes the anchor that pulls them into the depths. Furthermore, we are seeing a rise in forced migrations. As the sea ice retreats further north into deeper, less productive waters, bears are being pushed into oceanic regions where the prey density is almost zero. They are swimming harder and longer, moving into a biological desert, chasing a horizon of ice that may never materialize. This is the cruelty of the new Arctic. The bear is caught in a spatial trap. The distance between the food and the floor is expanding, and the energy required to bridge that gap is exceeding the energy the bear can possibly harvest. The long swim is no longer a journey between hunting grounds. For many, it is a slow, rhythmic march toward exhaustion, a final, desperate struggle against an ocean that is becoming far too large for a predator that is becoming far too small. But what if the greatest enemy of the apex predator isn't the cold, but the very chemistry of its own survival? To understand the true gravity of this crisis, we must look past the visible struggle of the swim and into the microscopic battlefield occurring within the bear's own cells. This is the metabolic paradox of the starving predator. The more they struggle to find food, the more they destroy the very machinery required to hunt it. When a polar bear enters a state of prolonged fasting, it undergoes a biological process known as walking hibernation. In a stable environment, this is a masterpiece of efficiency. The bear's metabolism slows, its heart rate drops, and it shifts from burning carbohydrates to burning its massive stores of adipose tissue, blubber. This fat is not just a fuel, it is a biological buffer, a slow-release energy source that keeps the bear's core temperature stable even as the Arctic wind howls. However, the current rate of ice loss has pushed this process into a state of metabolic breakdown. We are witnessing a shift from controlled fasting to a state of systemic starvation. As the lipid stores vanish, the body reaches a critical tipping point. To prevent immediate organ failure, the bear's biology initiates a desperate, scorched earth policy: autophagy. The body begins to systematically break down its own skeletal muscle to provide the glucose necessary to keep the brain and heart functioning. This creates a devastating feedback loop. As the bear consumes its own muscle tissue to survive the hunger, it loses the very strength required for the explosive power needed to hunt a seal. A polar bear relies on a burst of high-intensity energy to break through the ice or lunge at prey. But a bear in the throes of autophagy is a bear stripped of its power. It becomes a ghost of its former self, physically diminished, neurologically sluggish, and biologically incapable of the high-stakes violence that defines its existence. There is a lesser-known, yet equally terrifying, physiological cost: the loss of thermoregulatory control. Adipose tissue does more than provide calories. It acts as the primary insulator for the bear's internal organs. As the subcutaneous fat layer thins, the bear's ability to retain heat collapses. Even in sub-zero temperatures, a starving bear can suffer from a form of metabolic hypothermia. Their bodies are forced to divert precious, dwindling energy away from movement and toward the singular, exhausting task of simply maintaining a body temperature that allows life to persist. We are also seeing the impact of nutritional bankruptcy on the bear's hormonal landscape. The depletion of fats disrupts the endocrine system, specifically affecting the production of leptin, the hormone that signals satiety and regulates energy expenditure. In a starving bear, the hormonal signals become chaotic. The body is screaming for energy, yet the physical ability to acquire it has been eroded by the very hunger it is trying to satisfy. This is the weight of survival. It is not just the weight of a heavy, waterlogged body in the ocean. It is the crushing weight of an internal deficit that cannot be repaid. The bear is trapped in a race against its own biology, where every calorie spent on survival is a calorie stolen from the possibility of a future. In the modern Arctic, the struggle is no longer just about finding food. It is about the terrifying reality that the bear is slowly consuming itself to stay alive. But what happens when the body's desperate struggle to survive meets the one place where life is supposed to be most secure? If the starvation of the individual is a slow erosion, the destruction of the den is a sudden, catastrophic collapse. To understand the next generation, we have to look away from the open ice and into the silent, white sanctuary of the snow den. For a pregnant female polar bear, the den is not merely a shelter. It is a biological fortress, a carefully engineered microclimate designed to protect the most vulnerable stage of their existence. As the mother enters her winter fast, she seeks out deep, stable snowdrifts, often on sea ice or coastal hillsides, to excavate a chamber. Inside this womb of ice, a miraculous thermal miracle occurs. Through a process of metabolic heat retention and the insulating properties of compacted snow, the temperature inside a den can remain significantly higher than the lethal Arctic winds outside. It is here, in this controlled stillness, that the cubs are born, blind, hairless, and entirely dependent on their mother's milk. But the architecture of these nurseries relies on a very specific, very fragile foundation: the quality and depth of the snowpack. We are now witnessing a phenomenon that researchers call den instability. Because the Arctic is warming at nearly 4 times the global average, the traditional patterns of snowfall are being replaced by unpredictable cycles of freezing and thawing. When a heavy rain-on-snow event occurs, a phenomenon becoming increasingly common as the atmosphere holds more moisture, the snow does not stay fluffy and insulating. Instead, it undergoes a phase change. It melts slightly and then refreezes into a dense, impenetrable layer of ice. This creates a twofold crisis. First, the insulation value of the snow collapses. The air pockets that once trapped warmth are replaced by solid ice, causing the internal temperature of the den to plummet. For a newborn cub, whose ability to thermoregulate is almost non-existent, even a slight drop in temperature can be fatal. Second, the structural integrity of the den is compromised. In a stable Arctic, a den is a permanent sanctuary for months. In the modern Arctic, these nurseries are becoming transient and precarious. Rapid melt cycles can cause the ceiling of a den to collapse under its own weight, or worse, cause the entire structure to slide down a coastal slope, crushing the occupants within. There is a more insidious, less visible threat as well: the salinity shift in coastal dens. As permafrost melts and sea ice retreats, the movement of saltwater into previously frozen terrestrial landscapes can alter the chemistry of the snow and soil. This changes the way snow compacts and how it holds moisture, disrupting the delicate hygroscopic balance required to maintain a stable den environment. The result is a biological bottleneck. We are seeing a terrifying disconnect between the bear's ancient reproductive instincts and the chaotic reality of their changing habitat. A mother may expend her final, precious reserves of energy to excavate a perfect den, only to have the changing climate dismantle it before her cubs have even opened their eyes. The denning crisis is the ultimate expression of the Arctic's broken cycle. It is where the metabolic struggle of the mother meets the environmental volatility of a warming world, creating a gap in the timeline of the species that may soon become impossible to bridge. When the nursery fails, the future of the White Kingdom fails with it. If the collapse of the den represents the failure of the architecture, then the failure of the mother represents the depletion of the very fuel that keeps that architecture alive. To understand the true cost of a warming Arctic, we must look past the physical structure of the den and into the internal, microscopic battle occurring within the mother herself. This is the silent, physiological tragedy of maternal sacrifice. In a stable ecosystem, a female polar bear undergoes a process of profound biological preparation. She enters her den in a state of hyperphagia, having stored massive quantities of adipose tissue, fat, to sustain her through months of fasting. This fat is not merely a calorie reserve, it is a sophisticated biological bank account. It provides the energy for her own thermoregulation, the fuel for the labor of birth, and, most critically, the raw materials for her milk. But as the hunting season shrinks and the ice retreats earlier each year, many mothers are entering their dens in a state of nutritional bankruptcy. This creates a devastating biological paradox. A polar bear's milk is one of the most energy-dense substances in the animal kingdom, containing upwards of 30 to 40% fat. This extreme concentration is essential for the cubs to rapidly develop the blubber layers required to survive the Arctic chill. However, producing this liquid gold requires a massive metabolic investment. For a nursing mother, the caloric demand is astronomical. She is essentially running a high-performance engine on an empty tank. As her body enters a state of prolonged starvation, a process known as catabolism begins. To keep her brain functioning and her heart beating, her body begins to break down its own tissues. In a desperate bid to keep her cubs alive, the mother's body will prioritize the production of milk over her own survival. She will systematically cannibalize her own muscle mass and deplete her vital organ reserves to ensure the cubs receive the lipids they need. This is where the science becomes truly harrowing. Researchers have observed that in malnourished mothers, the body may undergo lactational amenorrhea or extreme hormonal suppression, but even more devastating is the phenomenon of maternal attrition. This is a physiological tipping point where the mother's body can no longer maintain the minimum metabolic threshold required to produce milk. When this happens, the milk doesn't just become less nutritious, it ceases to exist. The cubs, despite being born into a sanctuary, find themselves in a desert of nutrition. They may have a warm den, but they lack the chemical fuel to grow. They become smaller, weaker, and more susceptible to the very temperature fluctuations we discussed earlier. Furthermore, we are seeing a terrifying new variable: the lipid toxin correlation. As mothers metabolize their shrinking fat stores to feed their young, they are also inadvertently releasing a hidden legacy of human impact. Many persistent organic pollutants, chemicals like PCBs that have traveled from distant industrial centers, are lipophilic, meaning they are stored in the fat cells. As the mother burns her fat to create milk, she inadvertently concentrates these toxins, delivering a concentrated dose of environmental poisons directly into the bloodstream of her offspring during their most vulnerable developmental window. Maternal sacrifice was once an evolutionary strategy designed to ensure the survival of the strongest. But in the modern Arctic, it has become a biological trap. The mother is no longer just fighting the cold. She is fighting her own biology, sacrificing her very essence to feed a future that the changing climate may no longer have a place for. But what happens when a sacrifice, no matter how profound, is simply not enough to tip the scales of survival? If the mother's body is the engine of the next generation, then the survival rate of the cubs is the ultimate metric of a species' viability. In a healthy Arctic, the math of life is predictable. A healthy mother produces strong, robust cubs with high birth weights, giving them a mathematical buffer against the elements. But as we move from the internal struggle of the mother to the external reality of the cub, we see that this buffer is evaporating. The survival of a polar bear cub is not merely a matter of luck. It is a complex calculation of thermal regulation and caloric thresholds. A newborn cub is essentially a biological unfinished product. They are born blind, hairless, and incredibly small, weighing only about 600 grams. They are entirely dependent on the thermal inertia provided by their mother's milk and the insulation of their developing blubber. In recent years, researchers have begun documenting a terrifying shift in recruitment rates, the number of cubs that actually make it to weaning age. In some subpopulations, such as those in the southern Beaufort Sea, we are seeing a precipitous decline. It is not just that fewer cubs are being born, it is that those who are born are failing to cross the threshold of adolescence. One of the most overlooked factors in this decline is the metabolic ceiling. A cub requires a precise, escalating caloric intake to fuel its rapid growth. If the mother's milk density drops below a critical lipid threshold due to her own starvation, the cub hits a metabolic ceiling. It simply cannot grow fast enough to outrun the seasonal shifts. They enter a state of stunted development, where their physiological processes slow down to conserve energy, leaving them too weak to hunt or even to navigate the increasingly fragmented ice. This creates a secondary, more insidious threat: the loss of the learning window. Survival in the Arctic is a learned behavior. Cubs must spend their first years observing their mother's hunting techniques, learning how to sense the subtle movements of a seal beneath the ice or how to navigate the treacherous leads of open water. But as mothers become increasingly desperate and lethargic due to malnutrition, this apprenticeship is being severed. A mother struggling to maintain her own heartbeat does not have the energy to teach. We are witnessing a breakdown in the intergenerational transfer of knowledge. Furthermore, we must consider the impact of fragmentation mortality. In the past, a cub could follow its mother across a relatively continuous sheet of sea ice. Today, that journey is often interrupted by vast stretches of open water. For a cub, a long-distance swim is not just an exhausting task, it is a death sentence. Their smaller body mass means they lose heat to the water much faster than an adult. They lack the massive subcutaneous fat stores required to combat the conductive heat loss of the Arctic Ocean. A single unplanned swim, forced by the premature breakup of ice, can result in the immediate loss of an entire year's reproductive effort. When we look at the data, the picture is stark. We aren't just seeing individual deaths, we are seeing a systemic failure of the replacement rate. The biological cycle is breaking. The cubs are not reaching maturity, the elders are not being replaced, and the population is beginning to tilt toward an inevitable, silent collapse. But what if the greatest threat to their future isn't just the lack of food, but the inability to find one another? In the natural world, survival is often a game of numbers, but for the polar bear, it is becoming a game of geography. As the vast, continuous highways of sea ice dissolve into a scattered archipelago of melting flows, we are witnessing a phenomenon known as habitat fragmentation. To the naked eye, it looks like a landscape of broken glass. To the polar bear, it is a series of biological prisons. When the ice breaks apart, it does more than just create physical barriers. It creates genetic ones. In a stable Arctic, polar bears exist in a state of fluid movement. Large-scale migrations allow for gene flow, the essential mixing of DNA between different subpopulations. This movement ensures that the species remains a single, robust, and adaptable entity. But as the distance between viable ice patches grows, these migratory corridors are being severed. We are seeing the emergence of genetic islands. When a population becomes isolated, the biological clock begins to tick toward a concept known as inbreeding depression. In a small, closed group, the pool of available mates shrinks. When closely related individuals are forced to mate, the likelihood of recessive, deleterious mutations surfacing increases exponentially. This isn't just a theoretical risk, it is a physiological reality. Inbreeding can lead to reduced fertility, higher rates of congenital physical deformities, and a weakened immune system. A bear that is genetically homogenized loses its ability to adapt to new pathogens or shifting environmental stressors. They become a biological monoculture, and in nature, monocultures are incredibly easy to destroy. Furthermore, we must look at the concept of effective population size. This is a scientific metric that differs from the total number of bears you might see on a map. The effective population size accounts only for those individuals who are actually contributing to the next generation's gene pool. As the ice retreats, many bears become sink populations, groups that exist in marginal habitats where they may survive, but they are too isolated to ever successfully reproduce or introduce new life into the wider species. They are, quite literally, the walking dead of the Arctic. There is also the subtle, invisible danger of genetic drift. In small, isolated groups, certain genetic traits can vanish simply by chance. If the only 3 bears in a particular sector carrying a specific trait, perhaps a slightly higher tolerance for warmer water or a more efficient metabolic rate, fail to find a mate before they die, that evolutionary advantage is lost forever. The species is being stripped of its evolutionary toolkit, piece by piece. We are witnessing a paradox of the modern age. The polar bear is still physically present, but its biological future is being erased. They are becoming a collection of disconnected fragments, drifting further apart on a melting sea. As the physical connections of the ice disappear, so too does the invisible thread of DNA that holds the species together. We are not just watching a loss of habitat, we are watching the slow, quiet unraveling of a genome. The White Kingdom is not just melting. It is fracturing, leaving behind a species that may soon find itself perfectly adapted to a world that no longer exists, but lacks the genetic diversity to survive the one that does. How do you teach a predator to hunt when the very platform it relies on is vanishing? For a polar bear, hunting is not an instinctual reflex like a shark strike. It is a complex, learned discipline, a generational transfer of knowledge that requires patience, stillness, and an intimate understanding of the ice. In a stable Arctic, this education is a slow, ritualistic process. A mother bear spends months teaching her cubs the art of the still hunt, the ability to sit motionless by a seal's breathing hole, often for hours, waiting for the microscopic ripple of life that signals a meal. This is a high-stakes classroom. The cubs must learn to interpret the subtle acoustics of the ice, distinguishing between the shifting of a floe and the heavy breathing of a ringed seal. They must master the stalk, moving with a weightless grace across the snow to avoid triggering the seismic sensors, the sensitive whiskers and vibrancy of their prey. This knowledge is passed down through tactile experience and observation, a biological inheritance that takes years to perfect. But the curriculum of the Arctic is changing faster than the cubs can study. As the sea ice thins and becomes more mobile, the traditional, still hunt is becoming increasingly unreliable. The ice is no longer a solid, predictable stage. It is a chaotic, drifting mosaic. For a cub, learning to find a breathing hole is one thing. Learning to find a breathing hole on a piece of ice that is actively rotating or breaking apart is an entirely different challenge. The spatial memory, required to navigate a consistent hunting ground, is being rendered obsolete by a landscape in constant, unpredictable motion. Furthermore, we are seeing a breakdown in the energy-to-reward ratio of their education. In the past, a successful hunt provided a massive influx of lipids, the high-density fats essential for growth and insulation. Today, many cubs are being taught to hunt in areas where the prey density is plummeting. They are practicing their skills on an empty stage. This creates a physiological crisis known as nutritional developmental delay. If a cub does not reach a specific threshold of body mass during its first 2 years, its metabolic rate cannot support the massive energy expenditure required for the next stage of life. They are essentially learning the mechanics of survival without the fuel to execute them. There is also a more insidious problem. the loss of the specialist advantage. Polar bears are extreme specialists, evolved to exploit a very narrow niche. As the ice retreats, cubs are being forced to attempt opportunistic foraging, scavenging for bird eggs, kelp, or even terrestrial carrion. While this might seem like adaptability, it is actually a biological trap. These alternative food sources are calorically impoverished. A cub can spend more energy searching for a handful of goose eggs than the eggs themselves provide in sustenance. This is a metabolic deficit that begins in infancy. We are witnessing a profound educational crisis in the natural world. The ancient, reliable lessons of the mother are being met with a landscape that no longer follows the rules. The cubs are being handed a textbook written for a world that has already disappeared, leaving them to master the art of a hunt that is becoming a ghost of itself. What happens when the classroom itself collapses? If the hunt is the curriculum of survival, then the den is the sanctuary where the future is forged. In the Arctic, a maternity den is not merely a shelter. It is a highly specialized biological incubator. To create one, a pregnant female must undergo a period of walking hibernation, a physiological marvel where her body enters a state of dormancy, slowing her heart rate and metabolism to conserve every precious joule of energy. She seeks out deep, stable snowdrifts, often on land or on thick, multi-year sea ice, to excavate a chamber that provides thermal insulation against the lethal Arctic winds. Inside these frozen womb-like structures, the miracle of life unfolds in near-total darkness. For 3 to 4 months, the mother does not eat, drink, or even defecate. She relies entirely on her accumulated adipose tissue, her fat stores, to fuel both her own vital organs and the production of nutrient-rich milk. This milk is a biological masterpiece, containing up to 30 to 40% fat, a concentration far higher than that of most mammals, designed to rapidly build the thick insulating blubber layer her cubs will need to survive the thaw. But the foundation of this sanctuary is crumbling. Climate change is disrupting the very architecture of the denning season. As we have seen, the warming Arctic is causing snowdrifts to become unstable and unpredictable. We are seeing an increase in den collapse, where premature thaws or heavy, unseasonable rain events cause the snow to lose its structural integrity, crushing the delicate chambers and the life within. Even more devastating is the mismatch in timing. As the spring thaw arrives earlier each year, the period of time between a cub's birth and the moment it must emerge to hunt is shrinking. This creates a biological bottleneck. The cubs are being forced out of the safety of the den before they have reached the critical body mass required to endure the hunt. This leads us to a haunting phenomenon observed by biologists in dwindling subpopulations: the empty den. An empty den is a silent testament to a broken reproductive cycle. It is not always the result of a failed pregnancy, but often the result of a failed transition. When a mother bear enters her den, her reproductive success is a direct reflection of her pre-denning body condition. There is a mathematical threshold of fat, a critical lipid mass, below which a female's body will simply refuse to support a pregnancy, or, more tragically, will fail to produce enough milk to sustain the cubs once they emerge. We are increasingly finding abandoned dens where the mother, driven by a desperate metabolic deficit, was forced to abandon her litter to save her own life. Or, more frequently, dens that are discovered empty because the cubs never made it past the first few weeks of life, their tiny bodies unable to bridge the gap between the warmth of the den and the caloric vacuum of the outside world. The empty den is more than just a lack of life. It is a profound biological signal. It tells us that the energy economy of the Arctic has become insolvent. When the nursery fails, the species doesn't just decline, it loses its ability to replace itself. We are watching the slow, quiet erasure of the next generation, one silent, snow-covered chamber at a time. But what happens when the instinct to survive leads an apex predator into the jaws of a different kind of danger? When the sea ice retreats, the polar bear is no longer a master of a frozen kingdom. It becomes a nomad in a landscape of scarcity. Driven by a metabolic desperation that overrides their natural fear of humans, these once elusive ghosts of the North are being forced into a new, perilous role: the scavenger. They are descending from the ice and into our world, not as hunters, but as foragers of our refuse. This is the search for scraps. To understand why a creature designed to hunt ringed seals is suddenly rooting through a landfill in Churchill or prowling the outskirts of Longyearbyen, you have to understand the caloric math of a starving bear. A polar bear requires massive amounts of lipid-dense fuel to maintain its thermoregulation and muscle mass. A discarded piece of human food, a scrap of meat, a container of grease, or even high-sugar processed goods represents a concentrated, albeit dangerous, caloric windfall. In the eyes of a starving bear, a garbage bin isn't just trash. It is a high-stakes gamble against starvation. However, this shift in diet is a biological trap. We are witnessing a phenomenon known as nutritional mismatch. The polar bear's digestive system is evolutionarily fine-tuned for high-fat, high-protein marine lipids. It is not designed to process the complex carbohydrates, refined sugars, or high sodium levels found in human waste. When a bear survives on these scraps, it may stave off immediate hunger, but it suffers from chronic metabolic dysfunction. We are seeing reports of bears exhibiting symptoms of systemic inflammation and gastrointestinal distress, essentially poisoning themselves with the very calories that keep them moving. Furthermore, this search for scraps forces a breakdown in the bear's natural spatial ecology. Traditionally, polar bears avoid human settlements to minimize the risk of conflict. But as the hunger gap widens, the biological drive to avoid starvation is overriding the instinctual drive for self-preservation. This brings them into the human-wildlife interface, a zone of extreme volatility. This proximity creates a lethal feedback loop. As bears become habituated to human food, they lose their natural wariness. They become problem bears. In the scientific community, we track this through habituation scales, where a bear moves from being wild to food-conditioned. Once a bear learns that a human settlement is a source of easy calories, it will return, often with increasing boldness. This inevitably leads to conflict. In many Arctic communities, the response to a food-conditioned bear is not coexistence, but removal, often through lethal force. It is a tragic irony of the modern era. The very tools we use to sustain our civilization, our waste, our settlements, our expanded footprint, are becoming the accidental lures that draw these magnificent predators into a fatal confrontation with humanity. The bear is no longer searching for the seal beneath the ice. It is searching for the shadow of a human, chasing a caloric ghost that offers life in the short term, but guarantees a confrontation that ends in death. The hunter has become the scavenger, and in that transition, the dignity of the species is being eroded alongside its physical strength. But if the bear is a scavenger chasing a caloric ghost, what happens to the people who have shared this frozen frontier for millennia? For the indigenous peoples of the Arctic, the Inuit, the Yupik, and the Inupiat, the disappearance of the sea ice is not just an environmental statistic, it is the unraveling of a cultural tapestry. For generations, these frontline communities have existed in a state of sophisticated equilibrium with the Arctic ecosystem. They are not mere observers of the North, they are part of its biological rhythm. But as the ice thins and the bears move closer to the doorsteps of human settlements, that ancient rhythm is being replaced by a discordant note of fear and instability. We often speak of climate change as a distant, abstract threat, but for these communities, It is a tangible, daily erosion of sovereignty and safety. The same melting permafrost that destabilizes the bear's hunting grounds is also buckling the foundations of Arctic homes, cracking roads, and swallowing infrastructure. As the landscape shifts, the traditional knowledge passed down through oral histories, the Inuit Kajimajitukenggit, is being challenged by a world that no longer behaves according to the ancestral rules. The ice, once a reliable highway for travel and hunting, has become an unpredictable, treacherous labyrinth. This environmental volatility creates a profound psychological burden known as solastalgia, the distress caused by the transformation and loss of one's home environment while one is still living in it. It is a unique form of grief, watching the very land that defines your identity become unrecognizable. But the crisis is not merely one of identity, it is one of survival. As polar bears become more food-conditioned and emboldened, the safety of Arctic villages is compromised. In many remote settlements, the presence of a bear is no longer a seasonal rarity, but a constant, looming threat. This necessitates an expensive and exhausting cycle of monitoring, deterrent deployment, and, inevitably, the lethal management of problem animals. For a community already struggling with the high costs of Arctic living, the logistical burden of managing wildlife conflict is immense. Furthermore, we must look at the geopolitical dimension of this frontline. As the ice recedes, the Arctic is no longer a closed, quiet sanctuary. It is being reimagined by the rest of the world as a new frontier for resource extraction. The resource rush, the push for oil, gas, and rare earth minerals, is moving northward, driven by the very warming that is destroying the ecosystem. This brings a new kind of encroachment: industrial noise, increased shipping traffic, and the potential for catastrophic oil spills in waters that are nearly impossible to clean. For the frontline communities, this represents a double-edged sword. The economic promises of industry clash violently with the fundamental need to preserve the subsistence lifestyle that has sustained them for centuries. They find themselves caught in the crossfire between global energy demands and the biological necessity of a stable Arctic. The struggle of the polar bear and the struggle of the indigenous Arctic peoples are two sides of the same coin. They are both fighting for a foothold on a landscape that is literally melting away. To witness the plight of the bear is to witness the destabilization of a human way of life. In the Arctic, the loss of the ice is not just a change in weather. It is a profound disruption of the sacred contract between the land, the predator, and the people who call it home. What if the very catastrophe destroying the Arctic is also the key that unlocks its gates to the rest of the world? As the white expanse of the Arctic Ocean retreats, it reveals something that has been hidden beneath the ice for eons: a massive, untapped treasury of wealth. For decades, the Arctic was a fortress of frost, an impenetrable barrier that kept global industry at bay. But the warming climate has acted as a master key, unlocking the most significant geopolitical scramble of the 21st century. This is the resource rush, and it is driven by a cruel irony. The more the ice melts, the more the world rushes in to exploit the very landscape that is vanishing. Beneath the receding shelf lies a geological jackpot. Estimates suggest the Arctic holds roughly 13% of the world's undiscovered oil and 30% of its undiscovered natural gas. These are not just numbers on a spreadsheet. They represent the lifeblood of global energy markets. Alongside these hydrocarbons lie vast deposits of rare earth elements, minerals like neodymium and dysprosium, which are essential for the high-tech components of our green revolution, from electric vehicle motors to wind turbines. We are witnessing a paradoxical cycle. The minerals required to fight climate change are buried in the very region being ravaged by it. But the intrusion is not limited to what lies beneath the seabed. The melting ice is opening the Northern Sea route and the Northwest Passage, maritime arteries that could shave weeks off the transit time between Europe and Asia. This isn't just about faster shipping, it's about the militarization and industrialization of the high north. As these lanes become navigable, they bring a constant, low-frequency hum of diesel engines and massive propellers. For the polar bear, this is a form of invisible sensory warfare. Polar bears rely on a world of silence to hunt. Their ability to detect the subtle movements of a seal through the ice is their greatest evolutionary asset. The introduction of industrial noise pollution can mask the sounds of prey and disrupt the acoustic environment that many Arctic species depend on for navigation and communication. Furthermore, the rush brings the shadow of chemical contamination. In the remote Arctic, we see a phenomenon known as Arctic contaminant loading. Persistent organic pollutants, or POPs, travel from industrial centers in the mid-latitudes via atmospheric currents, eventually settling in the Arctic snow and water. As we increase industrial activity, drilling, shipping, and mining, we are not just introducing new risks like catastrophic oil spills, which are nearly impossible to remediate in sub-zero, ice-choked waters, but we are also concentrating these legacy toxins. These chemicals bioaccumulate. They move from the smallest plankton to the fish, and finally, into the fat stores of the polar bear. For a predator that relies on consuming massive quantities of blubber to survive, this means they are inadvertently consuming a concentrated dose of the world's industrial waste. The resource rush transforms the Arctic from a biological sanctuary into a global extraction zone. It turns a delicate, slow-moving ecosystem into a high-stakes theater of economic competition. As the drills descend and the tankers pass, the polar bear is no longer just fighting the heat. It is fighting a world that has arrived to claim the remains of its home. But what happens when the silence of the North is shattered not by the cracking of ice, but by the rhythmic, mechanical thrum of global commerce? As the ice barriers dissolve, the Arctic is being reimagined as a shortcut for the world's most massive vessels. The emergence of the Northern Sea route and the Northwest Passage represents a paradigm shift in global logistics, potentially reducing shipping distances by up to 40% compared to the Suez Canal. To the global economy, this is a revolution in efficiency. To the polar bear, it is the arrival of a relentless, invisible intruder. The primary threat is not always what we can see, but what we can hear. In the vast, open expanses of the Arctic, sound travels differently. The water acts as a conductor for low-frequency vibrations, allowing the deep, guttural drone of massive diesel engines to carry for hundreds, even thousands of miles. This is known as acoustic masking. For a predator that has evolved to hunt in near-total silence, this is catastrophic. A polar bear's survival depends on its ability to detect the micro sounds of a seal's respiration or the subtle scrape of claws against ice through the frozen crust. When the ocean is filled with the constant, low-frequency hum of heavy shipping, the bear's sensory landscape is effectively blinded. It is hunting in a world where the signal of its prey is drowned out by the noise of human progress. Beyond the acoustic disruption, these new maritime highways introduce a profound physical risk. The threat of ship strikes and the terrifying reality of oil spills in a frozen desert. Unlike the warm waters of the Gulf of Mexico, where oil can be dispersed by sunlight and microbes, the Arctic is a graveyard for pollutants. In sub-zero temperatures, oil becomes highly viscous, thick, and nearly impossible to recover. It becomes trapped beneath moving ice floes, spreading through the very cracks and channels that polar bears use to navigate and hunt. A single spill in these waters wouldn't just be an environmental disaster. It would be a permanent alteration of the habitat, coating the sea ice in a toxic film that disrupts the entire base of the food web. Furthermore, the increased traffic brings the risk of invasive species, hitchhiking on the hulls of transoceanic vessels. Through a process called biofouling, organisms from warmer, southern waters are being introduced into the Arctic ecosystem. These invaders can outcompete native species, subtly reordering the biological hierarchy of the North. As the local fish populations shift to accommodate these new arrivals, the predictable prey cycles that the polar bear has relied on for millennia begin to unravel. We are witnessing the transformation of a sanctuary into a thoroughfare. The shipping lanes do more than just move goods from one continent to another. They carve permanent scars through the migratory corridors of the Arctic's most iconic inhabitants. The polar bear is being squeezed between two fronts: the retreating ice that limits its physical space, and the rising tide of industrial noise and chemical risk that pollutes the space that remains. The very paths that promise to connect the world are the same paths that are severing the polar bear from its ability to survive in silence. But what if the greatest threat to the Arctic's king isn't something he can hear or something he can see, but something he can only feel within his very cells? As we have seen, the physical landscape is being carved up by noise and machinery. But beneath the surface of the water and deep within the fatty tissues of the apex predator, a more insidious transformation is taking place. This is the story of the toxic trail, a phenomenon where the sins of distant industrial civilizations are being distilled into the very lifeblood of the Arctic. It begins with a process known as the grasshopper effect, or global distillation. You might wonder how a factory in a temperate, distant land can impact a creature in the frozen north. The answer lies in the volatile nature of persistent organic pollutants, POPs. These chemicals, such as PCBs, DDT, and certain flame retardants, do not simply disappear when they are released into the atmosphere. Instead, they evaporate in warmer climates, hitchhiking on air currents and traveling toward the poles. When they reach the frigid Arctic, they condense and fall with the snow. The Arctic acts as a planetary trap. Once these chemicals arrive in the cold, they are locked into the ecosystem, unable to evaporate back into the atmosphere. They settle into the snow, melt into the sea, and enter the base of the food web. This is where the science of biomagnification begins its deadly work. It starts with microscopic phytoplankton, absorbing trace amounts of these toxins. Tiny zooplankton eat the phytoplankton, and small fish eat the zooplankton. At each step of this biological ladder, the concentration of the toxin doesn't just increase, it multiplies. By the time these chemicals reach the ringed seals, the polar bear's primary source of energy, the toxins have reached levels thousands of times higher than they were in the surrounding seawater. And for the polar bear, the very thing they need to survive is becoming their greatest liability. To endure the lean months of fasting, the polar bear relies on its massive layer of adipose tissue, its fat stores. This blubber is a biological battery, providing the high-density calories required to maintain life in sub-zero temperatures. But in the modern Arctic, this fat is no longer just a source of energy. It is a chemical reservoir. Because many of these industrial pollutants are lipophilic, meaning they are fat-soluble, they migrate out of the bloodstream and sequester themselves within the bear's blubber. The bear is, quite literally, a walking vessel of concentrated poison. The consequences are devastating and invisible. These toxins are endocrine disruptors, meaning they mimic or block the hormones that regulate growth, metabolism, and reproduction. We are seeing evidence of compromised immune systems, making bears more susceptible to diseases they might have once fought off. Even more tragic is the impact on the next generation. When a mother bear breaks down her fat stores to produce milk during the long winter denning, she isn't just passing on nutrients. She is mobilizing those stored toxins, transferring a concentrated dose of industrial chemicals directly into her cubs through her milk. The toxic trail means that even if we were to stop the melting of the ice tomorrow, the legacy of our industrial past would still be hunting the polar bear from the inside out. The predator is being poisoned by the very energy that was supposed to keep it alive. But what happens when a predator, poisoned by the very nutrients meant to sustain it, is finally forced to step off the ice and into the world of men? For millennia, the polar bear and humanity occupied two entirely different realms, one of frozen solitude, the other of terrestrial civilization. There was a boundary, a silent respect born of distance. But as the ice retreats, that boundary is dissolving. We are witnessing a collision of two worlds that were never meant to meet, a desperate intersection driven by the most fundamental of instincts: hunger. As the hunting season shrinks, the bear's biological imperative shifts from the sea to the shore. A starving bear does not see a village as a human settlement. It sees it as a high-calorie oasis. Driven by an unrelenting metabolic demand, they are increasingly drawn to the fringes of Arctic towns, lured by the scent of refuse, stored food, and even the remains of whale carcasses left by indigenous hunters. This is the genesis of a tragic paradox. In the eyes of a starving mother, a trash bin is a life-saving resource. In the eyes of a human community, that same bear is a lethal intruder. These encounters are rarely the cinematic battles of myth. They are often quiet, terrifying, and profoundly sad. When a bear enters a settlement, it isn't hunting for sport. It is scavenging in a state of nutritional desperation. Yet, the sheer scale of a polar bear, a creature that can weigh over 1,000 pounds and possesses a bite force capable of crushing bone, makes any proximity a high-stakes gamble. For the indigenous peoples of the North, such as the Inuit, this encroachment creates a complex, heartbreaking tension. For generations, the bear has been a respected neighbor and a vital part of the cultural fabric. But as the ecosystem destabilizes, the bear is becoming unpredictable. The traditional knowledge passed down through millennia is being tested by a landscape that no longer follows the old rules. When a bear enters a community, it isn't just a threat to safety. It is a symptom of a broken world. The tragedy deepens with the resource rush. As the melting ice opens the Arctic to global commerce, we are seeing a surge in industrial presence. The expansion of shipping lanes and the pursuit of oil and gas reserves beneath the seabed introduce a new kind of friction. It is not just the physical presence of humans, but the sensory invasion. The low-frequency hum of massive icebreakers and the seismic testing used for mineral exploration can travel hundreds of miles underwater, disrupting the acoustic environment that marine mammals rely on. We are effectively blinding the Arctic through noise, pushing the bears further into the path of human infrastructure. Ultimately, man versus beast is a misnomer. It suggests two opposing forces locked in a struggle for dominance. But in reality, this is not a battle of strength. It is a collision of consequences. The bear is not invading our world. It is being exiled from its own. We are not fighting a predator. We are witnessing the desperate, final movements of a king who has lost his kingdom, forced to seek sanctuary in the very places that contributed to his downfall. The conflict we see on the streets of Arctic towns is merely the visible symptom of a much deeper, much more silent war being waged against the natural order. If we were to look into a crystal ball, would we see a ghost or a survivor? For decades, the conversation around polar bears has been framed by uncertainty, but as our climate models grow more sophisticated, the fog of speculation is lifting, revealing a stark and mathematical reality. We are no longer just guessing, we are calculating the end. When scientists speak of extinction projections, they aren't merely talking about a single species disappearing, they are talking about a timeline of systemic collapse. Current projections from the IUCN and leading Arctic researchers suggest a harrowing trajectory. If greenhouse gas emissions continue at their current pace, we could see the loss of 2/3 of the global polar bear population by the year 2050. But the most devastating data lies further ahead, toward the turn of the century. By the year 2100, under a high-emissions scenario, the math becomes almost impossible to bear. Most subpopulations, the distinct groups of bears that inhabit specific regions of the Arctic, could face functional extinction. This doesn't just mean fewer bears, it means the biological death of the species. To understand why these numbers are so grim, we have to look beyond simple temperature rises and into the critical thresholds of Arctic biology. There is a concept known as the ice-free period. Every subpopulation of polar bears has a physiological limit, a maximum number of days they can survive without access to seal blubber before their metabolic reserves hit a point of no return. In the Beaufort Sea, researchers have noted that the fasting season is already stretching toward this breaking point. Once the ice-free window exceeds a specific number of days, the reproductive cycle breaks. Females become too thin to carry cubs to term, and even if they do, the milk is too calorie deficient to sustain them. This is the silent extinction, a population that doesn't die off in a single catastrophic event, but one that simply ceases to replace itself. Furthermore, we are seeing the emergence of genetic bottlenecking. As the sea ice fragments, the once vast, interconnected Arctic becomes a series of isolated islands of ice. This forces bears into smaller, disconnected pockets. When populations are isolated, genetic diversity plummets. Inbreeding becomes an inevitability, making the remaining bears more susceptible to disease and less able to adapt to a rapidly changing environment. We are witnessing the shrinking of a species' very blueprint. But there is a nuance in the data that many overlook. Extinction is not a uniform event. It will be a staggered, agonizing retreat. We will see the loss of the southern Hudson Bay populations first, followed by the more remote high Arctic groups. The extinction we are projecting is actually a series of local collapses that eventually leave the species as nothing more than a few scattered, struggling remnants in the most inaccessible corners of the planet. The data tells us that the clock is not just ticking, it is accelerating. These projections are not destiny, but they are a mathematical warning. They represent the logical conclusion of our current path, a future where the most iconic predator of the North becomes nothing more than a memory, a white silhouette in a history book, leaving behind an ocean that has forgotten how to be wild. But what happens to the world that remains when the king is gone? To understand the true scale of this loss, we have to look past the individual bear and into the very architecture of the Arctic food web. In ecology, there is a phenomenon known as a trophic cascade, a domino effect where the removal of a single apex predator triggers a catastrophic collapse that ripples down through every level of life, from the microscopic to the massive. In the Arctic, the polar bear is not just a resident, it is the regulator. By hunting ringed and bearded seals, bears perform a vital biological service. They manage the population density of these mid-level predators. Without the bear, the seal population would initially experience a deceptive, explosive surge. But this is a biological trap. An overabundance of seals would lead to an intense, unsustainable competition for food, eventually decimating the Arctic cod and the zooplankton that form the foundation of the entire sea. However, the cascade moves in ways that are even more subtle and perhaps more unsettling. One of the most overlooked roles of the polar bear is their contribution to the nutrient cycle of the frozen ocean. When a bear successfully hunts a seal, it doesn't consume the entire animal. The discarded remains, the scraps of blubber and meat, are left on the ice or fall into the water. These nutrient-rich pulses are essential. They provide critical caloric boosts to scavengers like the Arctic fox and various species of seabirds, and they fuel the microbial communities in the water below. This process, known as allochthonous input, means that the energy captured by a bear on the ice is actually redistributed to the deep sea. When the bears vanish, this vital bridge between the terrestrial ice and the marine depths is severed. The cascade also extends to the very chemistry of the Arctic. We are seeing a phenomenon where the loss of top-down regulation alters the behavior of the entire ecosystem. Without the constant pressure of a predator, the landscape of fear disappears. Prey species change how they move, where they rest, and how they graze on kelp and sea vegetation. This shift can lead to the overgrazing of underwater forests, which serve as the primary carbon sinks of the Arctic Ocean. In a cruel irony, the disappearance of a predator could actually accelerate the very warming that caused its downfall, by weakening the ocean's ability to sequester carbon. We are not just witnessing the end of a species, we are witnessing the unraveling of a complex, finely tuned biological machine. If the polar bear is removed, the Arctic does not simply become a bear-free zone. It becomes a broken ecosystem, a chaotic, unstable environment where the natural checks and balances have been erased. The loss of the polar bear is the first domino. Once it falls, the entire structure begins to lean. We are left to wonder, when the cascade is complete and the rhythms of the North have been fundamentally rewritten, will there be anything left of the White Kingdom at all? Or will we be left with a silent, hollowed-out ocean, struggling to find its balance in a world that has lost its pulse? If a single species can destabilize an entire ocean, what does that say about the stability of our own? The plight of the polar bear is often framed as a tragedy of isolation, a distant, frozen drama playing out on a stage far removed from the streets of London, New York, or Tokyo. But this is a dangerous misconception. The Arctic is not a detached sanctuary. It is the Earth's thermal regulator, a massive white engine that dictates the climate of the entire planet. When we watch the polar bear struggle, we are not merely watching a victim of change. We are watching the canary in the coal mine for the global biosphere. In the scientific community, the Arctic is recognized as a critical indicator of planetary health. Because of a process called Arctic Amplification, the North Pole is warming nearly 4 times faster than the global average. This isn't just a localized weather pattern. It is a fundamental shift in the Earth's energy balance. As the sea ice melts, the planet loses its most effective shield against solar radiation. This is the albedo feedback loop in action. White ice reflects 80% of the sun's heat back into space, but dark, open water absorbs 90% of it. As the bears lose their platform, the ocean absorbs more heat, which melts more ice, which warms the atmosphere further. The bear is the visual manifestation of a feedback loop that is accelerating toward a global tipping point. But the warning extends beyond temperature. The melting Arctic is a silent messenger of chemical and biological shifts that will eventually reach every coastline. As the permafrost thaws, the very ground the bears walk upon, it releases massive quantities of methane, a greenhouse gas that is 80 times more potent than carbon dioxide over a 20-year period. We are seeing the release of ancient carbon, gases that have been trapped for millennia, now fueling a cycle of warming that humanity can no longer easily control. Furthermore, the disappearance of the Arctic ice pack alters the very salinity and circulation of our oceans. The influx of massive amounts of freshwater from melting glaciers disrupts the thermohaline circulation, the Great Ocean Conveyor Belt. This global current system distributes heat around the world, regulating everything from the mild climates of Europe to the monsoon patterns of Asia. If the Arctic's freshwater surge becomes too great, we risk stalling these currents, potentially plunging entire continents into unpredictable, extreme climatic shifts. To look into the eyes of a starving polar bear is to see the biological cost of our modern existence. Their struggle is the physical evidence of a global atmospheric imbalance. They are the first to feel the heat, the first to lose their footing, and the first to succumb to a changing chemistry. The disappearance of the White Kingdom is not an isolated event in a remote corner of the map. It is a systemic failure of the Earth's life support systems. The polar bear is telling us that the boundaries of the natural world are being pushed past their breaking point. If we ignore the warning written in the melting ice, we aren't just losing a king. We are losing the stability of the world we all inhabit. The question is no longer just about the survival of the bear. It is about whether we can survive the consequences of its disappearance. Can we truly protect a kingdom that is fundamentally dissolving beneath our feet? As we stand at this precipice, the conversation must shift from mere observation to active, radical intervention. We are no longer in an era where conservation simply means setting aside a park or banning a hunt. In the Arctic, the very geography of survival is shifting, requiring us to move into entirely new conservation frontiers. Strategies that are as fluid and complex as the ice itself. One of the most critical, yet controversial, frontiers is the concept of managed relocation and genetic rescue. As subpopulations become fragmented by vast stretches of open water, the natural flow of genes is being severed. We are seeing genetic bottlenecks, where isolated groups of bears are forced to inbreed, weakening their immunity and their ability to adapt to a warmer world. Scientists are now debating whether we should intervene by physically moving individuals between isolated ice patches to mimic natural migration, or even utilizing advanced genomic technologies to maintain the species' biological resilience. It is a profound ethical dilemma. Do we preserve the wildness of the bear by letting nature take its course, or do we embrace the role of the architect to prevent a genetic dead end? Beyond biology, we are witnessing the rise of dynamic ocean management. Traditional conservation relies on static boundaries, lines on a map that define a protected area. But how do you draw a line around a habitat that moves, melts, and vanishes with the seasons? The new frontier utilizes real-time satellite telemetry and AI-driven predictive modeling to create moving protected zones. These are digital corridors that shift in real time, tracking the movement of the sea ice pack and the bears that rely on it. This allows us to dynamically regulate shipping lanes and industrial activity, closing off sectors to human encroachment exactly when and where the bears are most vulnerable. There is also a burgeoning movement in indigenous-led conservation. For millennia, the Inuit and other Arctic peoples have managed these lands through a deep, empirical understanding of the ecosystem. Modern science is finally recognizing that the most effective way to protect the Arctic is not through top-down Western mandates, but by integrating traditional ecological knowledge with modern technology. This means empowering local communities to lead the monitoring of ice thickness, bear movements, and even the health of the seal populations. It is a recognition that those who live on the front lines are not just witnesses to the change, but the most vital guardians of the remaining ice. Yet all these localized efforts, the genetic interventions, the digital corridors, the indigenous partnerships, are ultimately band-aids on a systemic wound. The most difficult frontier is not found in the Arctic, but in the halls of global policy. We are fighting a battle of carbon mitigation that is the ultimate form of conservation. Every fraction of a degree of warming prevented is a square kilometer of sea ice saved. The frontier of conservation is no longer just about saving a creature. It is about the stabilization of an entire planetary system. We are attempting to build a lifeboat out of policy, technology, and global cooperation. The success of these frontiers will be measured not by how many bears we can save in a zoo or a sanctuary, but by whether we can preserve the frozen stage upon which their epic, ancient drama is played. If the biological struggle is a battle for survival, then the political struggle is a battle for time. But how do you govern a landscape that refuses to stay still? As we move from the localized efforts of genetic rescue and indigenous guardianship, we enter the most complex arena of all, the geopolitical theater. The Arctic is no longer just a frozen wilderness. It has become one of the most contested pieces of real estate on Earth. As the ice retreats, it uncovers a treasure trove of untapped resources, natural gas, oil, and rare earth minerals, triggering a scramble for sovereignty among the Arctic 8 nations. This is the policy paradox. The very melting that threatens the polar bear's existence is simultaneously opening the door to the industrial activities that accelerate its demise. At the heart of this tension lies the fragility of international law. The primary framework governing these waters is the United Nations Convention on the Law of the Sea, or UNCLOS. While UNCLOS provides a structure for maritime boundaries, it was never designed to manage a world where the physical territory itself is liquefying. There is a growing legal gray area regarding extended continental shelves. As nations like Russia, Canada, and Denmark submit scientific data to claim seabed rights, they are essentially racing to map a territory that is transitioning from a permanent ice cap to an open ocean. The legal battle over who owns the Arctic seabed could inadvertently prioritize resource extraction rights over the environmental protections necessary to stabilize the climate. Furthermore, we face the challenge of transboundary governance. Polar bears do not recognize national borders. A single subpopulation may roam across the jurisdictional waters of multiple sovereign states. This creates a tragedy of the commons on a global scale. If one nation implements strict carbon regulations and protects migratory corridors, but a neighboring nation prioritizes the expansion of Arctic shipping lanes or offshore drilling, the conservation efforts of the first are rendered moot. The bear's survival depends on a level of international synchronization that our current political structures are ill-equipped to handle. Even more insidious is the concept of black carbon regulation. While much of the global policy debate focuses on CO2, scientists are increasingly pointing to the disproportionate impact of black carbon, soot from shipping, industrial activity, and wildfires. When these dark particles settle on the white Arctic snow, they decrease the albedo effect, absorbing solar radiation and accelerating melting at a rate far higher than CO2 alone. Yet, regulating black carbon is a diplomatic nightmare, as it requires unprecedented oversight of international shipping lanes and the enforcement of emission control areas in some of the most remote reaches of the planet. We are witnessing a clash between the short-termism of national economies and the long-termism required for planetary survival. To save the polar bear, policy must evolve from a system of territorial competition to one of planetary stewardship. We need more than just treaties. We need a fundamental shift in how we value the Arctic, moving from seeing it as a resource to be exploited to recognizing it as a global life support system that must be defended. The policy battle is not being fought with weapons, but with signatures, scientific data, and carbon quotas. It is a race to see if our capacity for cooperation can outpace the rate of the thaw. What if the end of a species is not a sudden crash, but a slow, quiet fading of the lights? As we have seen, the battle for the Arctic is being fought in the halls of diplomacy and the courts of international law. But while diplomats debate sovereignty and carbon quotas, the actual inhabitant of this shifting world is running out of options. We are approaching the tipping point, a threshold where the biological, the environmental, and the political collide to create a reality from which there may be no return. Current extinction projections are no longer mere academic exercises. They are becoming hauntingly precise. Most climate models suggest that if greenhouse gas emissions continue at their current trajectory, we could lose 2/3 of the global polar bear population by mid-century. By the year 2100, some subpopulations may not just be declining, they may be functionally extinct. But the loss of the bear is only the beginning of a much larger, more terrifying phenomenon: the trophic cascade. In ecology, a trophic cascade occurs when the removal of an apex predator triggers a domino effect throughout the entire food web. The polar bear is the keystone that holds the Arctic architecture together. Without them, the regulatory pressure on seal populations vanishes, leading to unpredictable shifts in marine mammal demographics. This, in turn, alters the nutrient cycling in the water column, affecting everything from zooplankton to the massive whales that migrate through these latitudes. When the king falls, the entire kingdom destabilizes. Yet, even as we look at the grim data, we must confront the canary in the coal mine reality. The polar bear is not an isolated victim, it is a biological indicator. The physiological stress we see in a starving bear, the shrinking fat reserves, the declining reproductive success, is a real-time readout of the planet's health. The Arctic is the Earth's cooling system, and the polar bear is the sensor telling us that the system is failing. But in the face of such overwhelming momentum, is there a way to pivot? The last stand is not just a eulogy, it is a call to define our legacy. We are currently witnessing a massive, unprecedented experiment in conservation science. We are seeing the rise of assisted migration theories and the implementation of marine protected areas that aim to create sanctuary corridors where ice is projected to persist longest. We are seeing a global movement to move beyond mitigation and toward restoration, not just of the ice, but of the stability required for life to persist. The survival of the polar bear ultimately rests on a singular, uncomfortable truth. The fate of the White Kingdom is decided by actions taken thousands of miles away in concrete jungles and industrial hubs. Their last stand is not being fought on the ice floes, but in our collective will to change. If we fail to act, the polar bear will become a ghost, a magnificent white shadow in our history books, a testament to a world we possessed but failed to protect. But if we succeed, we do more than save a species. We prove that humanity is capable of more than just consumption. We prove that we can be the stewards of the very world that sustains us. The clock is ticking, and the ice is thin. The question is no longer whether the bears can survive the thaw, but whether we can survive the consequences of letting them vanish.